Okay. Hello everyone. So in this section, I'll walk you on how you can add on how you can add slope data to your train set on the Zindi Malawi flood prediction competition on Zindi.Africa. So I'll be using we'll be getting our data set from Google's Earth Engine. So we'll be using a combination of Google's Earth Engine and QGIS to add features of our slope to our train set. So QGIS is an open source geospatial platform software. It's free. So, QGIS is free. So to download QGIS software, you can go to qgis.org. You can download for Windows. You can download for Mac OS, for Linux. It's more preferable when you download it, you should look out for the version with long-term stable release. So it's less bug, it's more bug free and than the latest. The latest has more bug than long term. So once you have your QGIS software, you can open it. Then the first thing we'll be doing now is we're going to load our train sets on this platform. So we'll go to our layer menu bar, add layer, add delimited text layer. Then we go to our file, then we add the train. Then from there, automatically you see the text our X and our I, where our Y axis, that's latitude and longitude. Then we add it here. So once we add, automatically it loads our train set to our. So automatically once it loads, as it loads, you see it takes the shape of southern Malawi. Now next we're going to do, we try and recreate the square from which this file were created from. So how are we going to go about it, creating the square? We are going to use a tool called Buffer. So Buffer a tool that allows you calculate measure distance to get area within a specific distance from a point. So we go to our toolbar, click on Buffer. On Buffer, you have your trains layer, or your input layer, use your train. Then for distance, we're going to use half of the size of a rectangle. From on Zindi platform, we're told that each coordinate represents the center of a rectangle, and a rectangle is from the platform is told that the rectangle contains 0.01 degree. So we're going to take half of the rectangle, that is 0.005. So for example, we'll make it 4 because a square has 4 sides. Then when this to square, you are interested in saving an output. So we'll click on this data sign. So we can call this train square. I click on save. Then run it. So it might take time depending on the speed of your laptop. So once this is successfully done, you can have your square. So let's see how, if the square it's really the square we're told on this platform. So we move our train up, so it comes first. So now from this view, we can now see that our square we created is actually, because you can now see that the square we created, that our train is actually from this square, because it's each of the train set is at the center of this square. So that really tells us that yes, our created square is correct. So the next thing we're going to be doing after this is to get our slope data from Google's Earth Engine using this really created square. So how do we go about it? So we go to Google's engine. We go to Zindi's platform under the data. Now this slope will be gotten from the elevation. Elevation was given to us, but let's see how slope can, if slope is going to improve our model. So we click on this link. Then it takes us to Google's Earth Engine platform. That's the slope data set. Then we click on open in editor. So on this opening editor, what we're going to be doing is we'll try and see how we can get data set from this on only our 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 shape file in Malawi. So what we first going to be, we'll try to add our data sets, our square. So we click on go to assets here, we click on new, click on shape file, then click on the select file. Now if you observe this shape file, now you observe that we created only one file and it's become 4 files. So we copy the 4 files, we load them to our platform. Then we can call this train square, or we can call it Malawi square. Okay, let's do train square. Everything being equal, we upload. Now for us to switch to show here how our work is progressing, click on the tags, you see the status of the data set we uploaded. So after that, so once it finished loading, some it might take time. You now have your data set here. So once it's been loaded successfully, you should have your file here. So once your data set has finished creating, it turns to a blue color. So if you refresh your assets, you should be able to see your train square. So now next thing we'll be doing is we'll try to extract this slope data set on only Malawi. So now I'm not really interested about USD, because from here map.center shows you the center of US. I'm interested about the center of Africa, that's of Malawi. So if I zoom in here, I can see Malawi here. So what I'm going to do is I'm going to change this map center to Malawi. So the first thing I'm going to be doing is I'll go to my inspector, click on here to get the coordinates, copy the coordinates here. Then I'll paste coordinates here. So if I run the script like this, I run it, you see the SRT and that's elevation data set, and this area it's around Malawi. Okay, so now let's go down to getting only this elevation data in Malawi. That when I mean Malawi, only the location in our train data set. So what I'm going to be, I'm going to import this our train square from where we created to this code editor script. So I click on this forward button, import into script. Then it loads my script here. So this first line shows you the importation of the elevation data set. Next line shows you that it gets the elevation data set from this image data. Then the next line converts the elevation data set to slope data set. We're interested in this slope data set. So we're interested in the slope data set So what we're going to be doing is, it's now this is the center of the slope. This is the layer that adds it. So now we're only interested about about the slope area in Malawi. So let's make a poly variable called Malawi. Also, let's call it slope. So we clip our slope data set to Malawi clip bracket. So on that, inside this clip function, we're going to call in our table. That's the Malawi shapefile we imported. So we call in table. So now when we are adding the layer, I won't add the whole slope into the whole wall. So we add only the slope of the Malawi. So we add Malawi slope here. So when we run the script, it might take time depending on so when we run this script, wow, you will now see it returns only the elevation data of Malawi. That's the slope of Malawi, and that's from our imported shapefile. So we are going to try to export only the slope of this area. So what we're going to be doing is to create this snippet I used. So it's called is a function. So I've copied, and so what this line of code does is it exports this created slope to your Google Drive. So say from here export.image.to-drive. So image, what's the image that is trying to export? Remember, we saved our clip data as Malawi, so I will tell it export Malawi. Malawi. What's the name of the data set? I still leave it as Malawi slope scale, then the region table, the region you want to export, then the file format JOTIF is a raster file exported as JOTIF. So we would then run this algorithm. So when we run it, sometimes it takes time. So if this loads and finish, you'll see our tags start running here. Shows here a tax is also click on this tax Malawi slope. Then we can call it, this is a tax name Malawi slope. Resolution, leave it at 30. So I want to save it to my drive. I want to save it to the root folder of my drive. I want to save the file name as Malawi slope. So I'll click on run here. So most time it takes time once you click on run. So it starts running from here. Then so once that stage completes, you would now see our task starts running from here. It shows you here that it's trying to create this file and send it to your Google Drive. Okay, so it takes a little bit of time, maybe about 10 to 15, or thereabout, depending on the state of the server at that moment. So once this process completes, it shows you a blue tick like this, and it shows a blue color like this, and it ticks. For now, I will wait for it to run now. So we'll move on to the next step. You go to your Google Drive and you search for the file. You named it. I named mine as Malawi slope. Sorry. So I'll search for Malawi slope, and now it shows me the slope, the slope file. So I'll click on it, and I will try to download it to my. I click on this button to download it to my PC, my laptop. So once I've been able to successfully download, this on my laptop, the next thing I'm going to be doing is I would go to my QGIS tool. QGIS tool. Now, this is my QGIS tool. Then I'll load this on my QGIS platform. So I'll go to my file name. It is named Malawi flood. So it's a raster file. So I'll click on it. It shows me my slope data set. Maybe I can color it to see how it looks like, but we're not doing analysis. Okay, I can color it to see how it looks like. So it shows me variation of high slope and low slope from 0 to 73, y0 in the low slope, and signifying red color, then green on a high slope. So next I'm going to be doing, I'm going to try to get the mean of this slope on each square. So if you check this square, so I'll try to get the mean of each slope on each square compared to getting the exact slope at this point. So getting the slope at this square, it's going to be more accurate because you tend to capture all the area in this environment. So what I'm going to be doing now is I'm going to use a tool called zonal statistics on this QGIS tool. So I'll go to my toolbox. I'll search for zonal statistics. So it shows up here. So for zonal statistics, as my input, I'll put in my raster file, and as my output, as my is a band one raster file. Then my vector layer, since I'm trying to get this statistics around this vector from this Malawi file. So and the name of the feature I'm trying to create is called slope. So I can call it slope underscore. Now this underscore is a prefix for different statistics to be calculated. So I can get the count, or let's say the number of slope in this area. The number of slope will not be relevant now, but I can get the sum, total sum of slope in that area. That will be relevant. I can get the mean slope in a particular rectangle. I can get the maximum slope. I can get the minimum slope. I can get the standard deviation of the slope, the median, or I can get different statistical calculation. But for the sake of this, I'm going to get the sum for this section. I'm going to get the sum, the mean, the max, and the mean slope. So I click on OK. Then I'm going to click on my run button. I click on the run here, and it starts loading. Most of the time it takes time depending on your PC computing power. So we're going to wait till it's complete. So when it's successful, I would now see my new feature. So if I click on it, if I close this, now for me to see if this attribute has been added, so I will go to my train square and click on open attributes table. So if I click on the open attribute table to see if it's added, so I'll click, it normally appends itself at the end of a column. So for me now, we can see that it has added a new feature to my train set. That's my train square set. So it has added a feature named slope mean, slope mean, slope mean, slope minimum. That's the minimum slope, the sum of total slope in each square, or that is each point in each rows in our train set, the maximum. So it calculated for all the 16,466 features. So that's it. So now since we now have this feature on our train set, we can now export this data. newly created, I can click on this, and then click on export, save. I can export save features as. Now, because I'm going to be training our data set, so I'll save it as CSV file format. So I can call this my data set. I can call this, I'll save it in my Malawi folder. I can call this my data set train with slope. So click on OK. If I want to retain, depending on how I'm going to be merging my data set. If I only want to extract just the newly created feature, I can deselect everything. But I think it's advisable when you're creating a new feature from this, you should select the X and the Y axis, and also select the square ID, then the new features you created, that is slope sum, slope swing, slope map, for easy merging with your train sets. Then from there on, I can now, I want to click on this. I don't want to save it on my map, so I can now click OK. So automatically it runs here. Now once this is done, I can find this. If I go to my folder where I saved this, I can now find it. I find it here, this folder. It's my folder. I saved it, so train with slope. Then from then I can add this feature to my train set and see how well it improves. So I hope this section is more helpful and useful to you guys. So you can also do same thing for other features you have in mind to add, the soil texture. Maybe you can also do distance to water body. You can also do different features, maybe different features on Google Earth. You can export them and extract features from here. Thank you.